Okay, children, I was really excited because I figured out how to make my mouse pointer into this yellow circle right here. That's really cool until you go to here. And it becomes a little dot. See the dot right there? It becomes a little dot. And you can't see it over here, big circle. I was trying to get it so I could do that. It doesn't do that. It's very, very irritating. By the way, all of this information can be found at nkinfinity.com. You can also go to Algebra 2 Common Core, Algebra 2 CC, and it'll take you there if that's easier. Anyway, let's get started. We're on 6-8. 6-8. There it is, right there. 6-8. Let's get away from purple. We'll go to blue. Anyway, write a sum to represent the future amount of a structured savings account if you deposit $250 into an account each month for 5 years that pays 3.6% per year. Well, if I'm doing it every month, how much is that per year? So let's go. We're going to start. So my summation is going to be sum of these things is, let's see, 250 times 12. Oops, that's 3,000. So every year it's going to be 3,000, and then we're going to do 3,000. Now it's growth. Oops, 3,000. So it's growth. We're going to do 1.036 to the n all over 1 minus 1.036, right? And that's what we got. And that's how much our value of our investment will be after 3 years. Again, the 3,000 just came from multiplying. Ooh, that's really cool. From multiplying 250 times 12, 2,000 per year. Oh, and how many we're going to do after 3 years. So I need to change this to a 3 years. So I go back to my calculator. You are going to be able to see my, ooh, even over there it doesn't show up. So let's see, 3,000. So control division, 3,000 minus 3,000 times 1.036 parenthesis raised to the 3 all over 1 minus, not 11, 1 minus 1.036, 1.036. Boom. Enter. $9,327. So $9,327.89. That's what we're going to have. All right. Let's go. That's your warm-up. Not all investments are compounded the same. Annually, monthly, quarterly, and continuously. This is the one that banks like to use right here, because they always get you. They give you your interest right away. Oh, every day you got to earn a little bit of interest, earn a little bit of interest, earn a little bit of interest. If it's compounded annually, we're going to use this formula where P, again, is your starting amount or principal amount. Principal or initial amount. R is your rate. Be careful with that. This is the big one. This is where people make a lot of mistakes. And T is time, of course. Be careful of times. Are you talking about minutes? Are you talking hours? Are you talking years? What are we talking about? Compounded continuously, they use this formula. Notice it's the exponential, the natural logarithm, where P is the same thing, R is the same thing, and T is the same thing. Nothing new there. Nothing new there at all. So other than the fact that it's now got a base of E rather than 1 plus R. That's my new base. And finally, this other thing. This is if it's going to compound monthly, then N would be 12. If it's compounded quarterly, then N would be, how many quarters are there? 4, good. And if it's done, what is it, semi-annually, then that would be, N would be 2. Those are the big ones. So let's just talk. Matt deposits $2,900 from his piggy bank. What? At 3.5% interest, by the way, which is unheard of. And what's his balance after 3 years if it's compounded monthly and annually? We're going to do it just a little bit different. And we're going to do it a little bit different. Let's do annual. I would do annually first. It's a little bit easier, but we'll tackle the hard one first. So let's see all the pieces to compounded monthly. We need n. Well, n's easy. N's 12. It's compounded monthly. What's my rate? Rate's easy. It's 3.5%. Why don't we convert that right to a decimal right now? Because this is where you're going to make your common mistakes. 0.035. Time, 3 years. All right, so let's get this rocking and rolling. So we're going to go a sub t, my amount now, is equal to, well, let's just do the generic one first. Start with our principal amount, which is $2,900 for my piggy bank. 1 plus 0.036 over, oh, it's 035. 035, sorry, I thought it was 6. 0.035 over 12 to the 12 times t. And then what's going in for t? 3. So I can just put that in. And we'll use our calculator. Oh, I'll get my thing back. All right, so 2,900, parentheses, 1 plus control division, 0.035 over 12, all raised to the 12 times 3. And it'll be worth 3220. 3220.57 and 57 cents. Be careful when you're talking about money. You always want to round to 2 decimals. All right. So what would it be if we compounded it annually? Compounded it. Now, then we're going to talk about what this actually means, and then I'll get you moving. So compounded annually says our a sub t. We're going to use those same numbers, so I'm not going to rewrite them. A sub t equals 2,900. 1 plus 0.035 to the 3. That's it. Simple, simple, stipple. All right. Let's see. What are we going to get? 2,900. Parenthesis 1 plus 0.035 parenthesis cubed. 3215.28. 3215.28. So, what constitutes the difference? This was for 3 years. This was for 3 years. So why am I making more money if I compound it monthly than when I compound it annually? So here's the difference. Let's say, let me show you, just me showing you an example. I could have done it over here probably. Let's say you invest $1,000. Okay? And you earn 3% annually. So at the end of the year, you will have earned 3%. Let's see what 3% of that is. So 1,000, this should be not a brainer, times 0.03, right? You earned $30. So you now have $1,030 at the end of the year. If you just earned 3%. So this is annually. The way it works monthly, if you do monthly, at the end of this month, you will have earned 3%, but 1/12 of that. So what we'll do is we'll say, okay, take 3 divided by 12. So this is how much money we earn, 3%, 0.03 divided by 12. This is the percent we earn, that's what we earn every month. So if I take 1,000 and I multiply it by 0.0025, I will have earned $2.50. So now at the end of month 1, I have $1,002.50. Well, I was earning 3% on this. Now I'm earning 3% on this, which is a bigger number. So that might be 1,000 and 520. Well, now I'm earning 3% on this number. Then I'm earning 3% on something a little bit bigger. And then 3% on something a little bit bigger. So you're always earning 3% on a slightly bigger number, as opposed to having to wait till the end of the year and then just make 3% on that $1,000. And that's why it's different compounding annually versus compounding continuously. Now you can imagine when you owe the banks money, they're going to compound it continuously. Just keep compounding and compounding and compounding them, like right down to the minute. But when they're going to pay you money, it's probably more like compounded annually, so they don't have to pay you as much. And that's kind of the nuts and bolts difference of compounding interest monthly versus annually. All right, I'll be back. Okay, we got Joe now. Here's Joe. Joe's going to deposit $5,000 into his account. He's going to get paid 3.2% interest right now. Let me go. 0.0372. Remember, if it's less than 10, it's going to be 0.0. Don't forget that fact. Find the balance after 4 years if the interest is compounded quarterly. Now, quarterly means n equals 4. Think about it. There's 4 quarters in a dollar, 4 quarters in a football game, 4 quarters in a basketball game, although I'm not sure maybe they play by half. So let's see. We're going to go through. Our principal amount is $5,000. Our rate is 3.72%, which we've already said is 0.0372. Basically, if it's less than 10, put 0.0 and then tack the number on, whatever's there. The time is 4 years. I think we're good. So let's see. A sub 4 is equal to 5,000. 1 plus, here's the rate divided by n, so 0.0372 divided by 4, because we're doing it 4 times a year, to the 4 times 4. 4 for the quarterly, and the other 4 for my actual time. All right, and I just type that in. So A sub 4 is equal to 5,000 parentheses 1 plus control division 0.0372 over 4 compounded quarterly, all raised to the 4 times 4. Could I have put 16 there? Of course. Equals $5,798.22. Now, they're not going to tell you what to round to for money, but if it's money and they don't tell you, you round to the 2 pennies. You round to cents. Round to the cents. Two decimal places. College savings plans have, such as the 529, allow individuals to put money aside now to help pay for college later. If one such plan offers a rate of 4% compounded continuously, how much should be put in college savings plan in 2005 to make sure you can pay for 1 year of college in 2015? Okay, let's see what we got. Compounded continuously means we're going to use the formula A sub t equals PERT, P-E to the R-T. So what's my principal amount? We don't know. What's my rate? I hope we know that, 4%. So 4% is less than 10. Be careful with it. We're going to use it as 0.04. That's 4%. Remember, rates are always the one that's going to get you messed up. And do I know time? My time is from 2015 to 2005. So my time is 10 years. Right? From 2005 to 2015, that's 10 years. Now, the only other thing I know is how much I really want to have. I want to have 31,000. So I actually know A sub t. So we're going to put 31,000 equals the principal amount. What do we have to put in today to have that money in the future if I get the money compounded continuously? E to the 0.04 times, what's my t? 10. So you might think this is an exponential and you have to turn it into logarithmic. It is not. The only thing I want to know what this is. So I have to divide by this mess, e to the 0.04 times 10, which is really just 0.4. So I'm going to divide both sides by that, e to the 0.04 times 10. So I go back over to the calculator, and I go control division, 31, 1, 2, 3, all over e to the 0.04 times 10. Again, I could just put 0.4 in there. And I get $20,799. So P equals $20,779.92. So if they ask that question, you'd say, hey, I have to invest $20,779.92 today so that in 10 years I can pay for my first year of college. Whew. College is not cheap, kids. College is not cheap. Start saving as much as you can now. In a savings account with an initial balance P and an annual interest rate R that is compounded continuously for T years. Compounded continuously. You got to start looking for these words right here. Compounded continuously. All right? If I see compounded continuously, that's P A sub T equals P E to the RT. All right, so let's just get going. Find the nearest tenth of a year, so I'm looking for T. This one's going to be one we're going to have to turn into a log, so that I can get a start at 1,200, end up with 3,200 at 8% interest. By the way, if you ever get a place to put your money in for 8% interest, take it. It's awesome, and put as much money as possible into it. All right, so what do we got? We got our principal amount. It's 1,200. We got our rate, which is 8%. Now remember, 8% is really 0.08. Don't make that silly mistake. Again, rates are always the common mistake. Time I don't know, but I do know A sub T. I do know what I want to end at, and what I want to end at is 3,200. So I know the final amount. All right, so let's get started. 3,200 is equal to 1,200 e to the 0.08 t. So this is one, whenever the variable is an exponent, you're going to have to use logarithms. And the first thing you want to do is get the weird thing alone. There's the weird thing. We want to get the weird thing alone by dividing by 1,200. Now, I talked to you yesterday about casting out zeros, right? Get rid of it, get rid of it. Now, of course, you could put it in your calculator, and it would tell you this is, 8/3? Whatever, just get rid of the zeros and use this. So now I know that e to the 0.08 t equals 32 over 12. And if you put that in your calculator, by the way, it's probably getting some crazy decimal. So don't do that. Just leave it like that. And now we got to sing. Oh, you thought we were done singing. Because we're going to change this exponential into a log equation. So log, all about that base. Wait a second. We have base E. When we have base E, I can't use that log. I have to use that special log, the natural log, ln. The base is E, and then these two things switch sides. Oh yeah, you forgot about that, didn't you? So 32 over 12 equals 0.08 t. Well, I still want to get t all by itself, so I'm going to come through, divide by 0.08, and divide by 0.08. Now remember, I can't put that e in the calculator. It's just understood to be there. But you got to remember, it's all about that base. That helps us write this piece. So we'll come back to our calculator, control division, do the natural log. See, I can't put the e in. The e is just, I know it's there. 32 over 12, 32 divided by 12, all over 0.04. And 24.5207. So t equals 24.5207. I don't even know what the questions ask anymore. In a savings account with an annual interest rate of P, how many years to the nearest tenth would it take to arrive at $3,200? It would take a long time. I have a different answer on my answer key. Weird. I have like half this amount. What did I do? Oh! I put 0.04. I'm like, man, I got like half that amount. And I kind of thought at 8% that was a lot. That was a lot of years. Let's do 0.08. Let's do it right. 12.26 years. Okay. So T, I thought that was a lot of years. For 8%, it's a really high percent. 12.26036. And it said round to the nearest tenth of a year, so T would be equal to 12.3 years. So take about 12.3 years to over double your money there. All right, sorry about that. I rounded the hundreds place. Doesn't really matter. All right, I will save, and I'll be right back with a weird face. I don't know why I said that. Okay, here we go. That's annoying. We're compounding quarterly. Remember, quarterly means that's 4 times a year. All right, so let's see. We want to take 5,300. We want to make it 7,000, and we got 9%. Again, 9% is ginormous. Take it. All right, so our principal amount, our starting amount, our initial amount. If we're trying to make money, our initial amount has to be, of course, the smaller number, 5,300. Our rate is 9%. Again, I'm going to rewrite that as 0.09 so I don't make any dumb mistakes, because that's where the mistakes are made, most of them. It's asking me how much time, so clearly that has to be the question mark. And I know my final amount. I know my A sub T. My final amount is $7,000. So we're going to take $7,000, compounded quarterly. So that's the one with the n's. Oh, and n equals 4. So 5,300. 1 plus the rate over 4, so 0.09 over 4 to the 4 times t. Again, I don't know what t is. And when you don't know an exponent, you know you're going to be using exponential or logarithmic functions in order to solve it. All right, so let's see what we got here. Let's clean this up slightly. I just want to figure out what that mess is. 1 plus 0.09 over 4. It comes out to be a nice number. 1 plus 0.09 divided by 4. It'll be a nice number. 1.0225. 1.0225. Okay. So here's my weird thing. Because it's got an exponent I got to solve. I'm going to have to eventually turn this into a log function because it is exponential. But the first thing I got to do is get that weird thing alone. So I'm going to divide by 5,300. Divide by 5,300. Again, I'm going to get rid of 2 zeros. I can't get rid of 3 because they both don't have 3. This goes. So what I end up with is 1.0225 to the 4t equals 70 over 53. And again, I'm just going to leave it as a fraction. Now we're going to bring out Megan. And Megan Trainer says we take this and it's all about the base. So log, all about the base. In this case, this base is right here. This is my exponent. This is my base. So log base 1.0225, and then these two things switch, of 70 over 53 equals 4t. Well, I'm not quite done. I still got to get rid of that 4, so I'm going to divide by 4 and divide by 4. So I know this looks really messy, but the calculator does it all for us. So we come over to our calculator. What is this? So come over to our calculator and we say, okay, calculator, first clear out all this mess. And we're going to say the log of 1.0225 of 70 divided by 53. Oops, I forgot to divide by 4. So I'm going to hit enter and then choose divide by 4. So 3.1257. So t equals 3.1257. rounded to the 10th. So rounded 10th. Did I mess up? Oh, I messed up on my answer key. All right, so round to the nearest 10th. What happened to my pointer? T equals 3.1 years. And that's probably right behind my head, so 3.1 years. All right, we're almost there. To the nearest 10th, how long will it take the sum of money to double if it's invested? To the nearest 10th, how long will it take a sum of money to double if it's invested at 12% compounded annually? Okay, let's write down the formula because something's weird. I only have one number. That's weird. So let's do A sub t is equal to my principal, 1 plus my rate to the time. Oh, I know the rate, right? Oh, okay. So I don't know the principal. I do know the rate. The rate is 12%, so 12%, so that's equal to 0.12. I don't know the time. In fact, the time is the thing I'm actually looking for. And I don't know A sub t. So at first glance, it's like, how do I do this problem? What am I going to do? Anybody? Oh, make up numbers. Perfect. Let's say I want to make up numbers. Let's say I invest $500. Well, it says how long will it take for the money to double? Well, if it was going to double, what would this number be down here? It would be 1,000. Oh, let's try those numbers. So my final amount is going to be 1,000. My initial amount is going to be 500. This is going to be 1 plus 0.12 to the t. I'm going to divide by, because I got to get the weird thing alone, I divide by 500, and I divide by 500. And you see that it makes no difference what numbers you use, because what number is that going to be? 2. Oh, 2 is equal to 1.12 to the t. See, if I picked $8, doubled would be 16, so here I would have 16 over 8. It would still be 2. So it doesn't matter what numbers you pick, it's still going to be 2. So now this is my equation that I have to solve. It's an exponential function. You know, Megan tells you that it's all about that base, so we got to turn this into a logarithmic equation. So log, all about the base, 1.12 of 2, these two things switch, of 2 equals t. And that's it. Go over to our calculator. We do control log 1.12 of 2. And I get 6.116. So t equals 6.116. Rounded to the nearest 10th, it would take t equals 6.1 years. All right, here we go. We're moving. 7. Let's see if I need to take a break. I don't need to take a break, but my computer might. Yeah. So during surgery, a patient must have at least 40 milligrams of an antibiotic in their system. The amount of antibiotic present K hours after administration of a 100 milligram antibiotic is given by this equation. So let's write that equation down. They gave it to us. You might as well write it down. P of K is equal to 100. There's our initial dose, 0.508 to the K. Now, since this is less than 1, this is exponential decay. And that should make sense. You put drugs in the body, eventually they go out. Eventually. How many hours to the nearest 10th will the nurse have to administer another dose to keep the levels of antibiotic high enough? So we know if it falls below 40 that we got to give them another dose. So the final amount is going to be 40. It's decay. It starts at 100. Remember, this is my principal amount right here. Here's my principal amount. And it's decaying. And so when it gets to 40, it's decayed enough. I got to give them some more. So my end number is going to be 40. So 40 is equal to 100.508 to the k. Now that seemed like a really, really hard problem until I just did that. Now we just do like we've just been doing. Divide by 100, get the weird thing alone. I get rid of 1 0. So I get 0.508 to the k equals 4 over 10. You could write it as 40 over 100. I don't actually care. So it's all about that base. This is an exponential. We're going to turn it into a log function. So log 0.508, and then these bad boys switch sides, of 4/10 equals k. So that's what I grabbed the calculator for. Why does it keep going to the wrong thing? So log 0.508 of 4/10 is just 0.4. So 1.3529. So k equals 1.3529. What's the question says? After how many hours to the nearest tenth will the nurse have to administer another dose? So she will have to administer another dose 1.4 hours after initial dose. That just wrote does. D-O-S-E. 1.4 hours. All right. We got one last question. Oh my gosh, it's so exciting. And for me, it's depressing. An exponential model of population growth is given by this equation. Let me write it. P of t is equal to P0, that's the initial amount, 10 to the kt. Holy crap. Where P0 is the original initial amount, original or initial population. T is the amount of number of years that has elapsed. If the population of the culture is 2,000 now and is 4,502 years, what is the value of k to the nearest thousandth? All right, see, we're going to end at 4,500. We're going to start at 2,000. We're doing 10. And we know that, what is this number of years? So we know that time is 2. So all we got to do is solve for k. It's an exponent we're solving for, which means we're going to have to use logs or exponential functions. So let's get rid of the 2,000, get the weird thing alone. I'll get rid of these 2 zeros. So what I end up with is 10 to the 2k equals 45 over 20. And I'm okay with that. Now, this is an exponential function. I need to turn it into a log function. So that's log. It's all about the base. Base 10. Oh, I don't even have to put that in. Log base 10 of 45 over 20 is equal to 2k. Now I just divide by 2. I divide by 2, and I get my answer. So let me start out with a fraction. Control division. So I'll do log. I'm going to show you I'm not even going to put the 10 in there because it's automatically understood to be there. 45 divided by 20. 45 divided by 20 all over 2. Now see how I put the 10 in there for me? I didn't have to put it in there. Put it in for me. 0.17609. So K equals 0.17609. I think that's enough because I think it's at around to the thousands place. So my answer is K equals 0.176. There it is, kids. That's it. That's all she wrote. That's the end. No more, no less. Wait. Yeah, nearest 1,000. Got a couple mistakes on my answer key, though, I got to fix. But, hey, it was fun. It was a lot of fun. I love being here with you guys. Thanks, man. And I didn't even have coffee. Catch you on the flip side. No, bye. Bye. No more word problems. I know you want more word problems because they were a lot of fun. But you got to go. Bye.